All right, welcome back. Now we're going to find the relationship between prime factorization and the greatest common factor. So first thing I want you to do is just find the prime factorization for these two numbers here. So 108 and 84. Okay, so that would be 54, 27, 3, 9, 3 and 3. So I have 2 2s and 3 3s. So 2 times 2 times 3 times 3 times 3. Okay, 84. Two, and that would be 4 and 2, 2, and that would be 21, and that would be 7 and 3. So that's 2 times 2 times 3 times 7. 7. Okay, so any factor, if we're looking at this, I'm going to change colors here. Any factor of 108, okay, the maximum number of 2's that could possibly be there are 2, right? And the maximum number of 3's that can be there are 3 3's, right? And if we're looking at 84, the maximum number of 2's that can be there is 2, 3's that can be there is 1, and 7's is 1. Okay, I'll just write that out so it's not confusing. There. Okay, so a common factor between the two numbers, 100, and 8 and 84, is it possible that they could have a 7 in it? So I just want you to think about that. Okay, so if you're looking, 108 doesn't have any 7's in it. So the factors that are its greatest common factor, any factors that it was have in common would not have a 7 in it. So would 84 and 108 have any common factors in common at all? And the answer to that is yes. So what is the maximum, if I'm looking, if they're going to have if they're going to have common factors, okay, so the maximum number of 2's that could possibly be there, and if I'm comparing here, the maximum number of 2's that they could have is 2. So 2 2's. And the maximum amount of 3's they could have, even though 108 has 3 3's, 84 only has 1, and the max number of 3's would have to be 1. So they could only have 1 2 in it and 1 3 in it. Okay, so like if we look here, or 2 2's in it, right? If we pair those up, and 1 3. So that would be the maximum number. So I could use these numbers here to find what the greatest common factor is between the two numbers. So the greatest common factor between 108 and 84 would be 2 times 2 times 3, which would equal, okay, so that'd be 4 times 3, which would be 12. So the greatest common factor between those two numbers is 12. And that would be very easy to test by going through and finding the factors. So if I'm looking at these two numbers, I already have the factors there. I can do the same thing here. I'm going to match up. So 40 and 60, these are the prime factorization, and I want to find the greatest common factor between them. So I can just pair these up. Obviously, I can't use this 2 and I can't use this 3. So the greatest common factor would be 2 times 2 times 5. Okay, so 4 times 5 would be 20. So the greatest common factor between 40 and 60 would be 20. Okay, so if I'm looking here, the prime factorization, I want you to do the prime factorization, and I want you to do exactly what we just did here. Okay, so just pause the video and find that for me. So this is 2 times 2 times 2 times 2, right? Because this is 4 times 4 is 16. So 2 times 2 is 4, times 2 is 8, and then 8 times 4, right? Or sorry, nope. 2 times 2 times 4, yeah, and then that's 3, and that's 6. So this would be 2 times 2 is 4, that's 6, that would be 24. Okay, so I have the prime factorization. Now I'm just going to match them up here. Okay, I'm not going to use those last numbers. So the greatest common factor between these two numbers would be, actually I'm going to put this over here because I'm going to add something else. 2 times 2 times 2, so this would be 4 times 2, so that would be 8. Okay, now what if I added another number in here? Okay, so now we're going to compare 30. So let's just factorize 30 here. 2 times 3, that's 6, times 5. All right, so now I need to find how the greatest common factor between these numbers here. If I look, this one and this one have a 3, but 16 doesn't. If there's no 5, so I know that I can't use 3s and 5s, so the only thing that's left here. So the greatest common factor between these three numbers would be 2.